Hello everyone. In this video, we'll be going over a number of sample problems on infinite geometric series. Okay, so let's get started. The first thing I'll do, like before, is I'll write down the formulas that we might need here. So the first formula is S infinity is equal to A over 1 minus R, where R is between -1 and 1. Remember that in order for us to use this formula, this condition has to first be met. And I'll also write down the sum of a geometric series for up to n terms in case we need to use that. So A 1 minus R to the n all over 1 minus R. Okay, so let's get started. So for the first question, it says determine if the series 4, 2, 1, and so on is convergent, and if so, find its sum. So when it's saying if it's convergent, it's really talking about the sum. We haven't talked about what it means for a sequence to be convergent. So this is talking about the sum of 4 plus 2 plus 1 plus ... And so the condition for an infinite geometric series being convergent was if the common ratio was between -1 and 1. So what's the common ratio here? Well, we can take one of the terms, and divide it by the previous one. So in this case, 4. And so we get that the common ratio is 1 over 2. Okay, this is between -1 and 1. So this is convergent. And to find the sum, we simply use our formula. A is 4, and our R value was 1/2. So this will be 4 over 1 minus 1/2 is 0.5, and 4 divided by 0.5 is 8. So the sum comes out to 8. All right, let's try the next problem. It says find the sum of the infinite geometric series. Okay, again, we have to first determine if this is convergent or not. Because if it's not convergent, I can't use this formula. Okay, we only are allowed to use this formula if the common ratio is between -1 and 1. So let's see, what is the common ratio? Well, it looks like the common ratio, again, here is 1/2, because we can see that the numbers are getting cut in half every time. And so the sum here will be A, which is 8, 1 minus R, and our common ratio is 1/2. And so this will come out to 8 over 0.5, or 16. So the sum is 60. Let's try the next one. So same drill. First, we'll determine the common ratio to see if it's convergent or not. And again, all of these, although I've written it as a sequence, it's talking about the series. So it's talking about when we take the sum of these terms. So when it says if it's convergent or divergent and what the sum is, it's talking about the sum of the series, right? The sum when we add the terms. All right, so the common ratio here is 1/3, right? 12 times 1/3 is 4. And so S infinity, the sum of the first infinite terms, is A, which is 12 over 1 minus 1/3. So that's going to be 12 over 1 minus 1/3 is 2/3. And so let's see how we can do this. This is 12 divided by 2/3. And 12 is the same as 12 over 1 divided by 2/3. And the way we divide fractions is to change the division. So we leave the first fraction untouched, we change the division to a multiplication, and we flip the second fraction. Oops, flip the second fraction. Okay, so this will come out to 18, right? If we multiply the top by the top and the bottom by the bottom, the top gives us 36 over 2 on the bottom, which is 18. So the sum is 18. Okay, number 4. For this series, when we add it up, determine if it is converges. So if it converges, and so if so, find the sum. Common ratio here is equal to -1/4. How did I get that? I grabbed one of the terms and divided by the previous one, okay, which will be -1/4. Okay, so we have a negative common ratio here, which is fine. And so S infinity is A, the first term, all over 1 minus -1/4. Okay, and so this will be 16 all over 1 minus -4 is the same, sorry, 1 minus -1/4 is the same as 1 plus 1/4. And 1 is the same as 4/4 plus 1/4, which will give us 5/4. Using the same fraction division multiplication trick I showed above, we get 16/1 times, here we get 4/5. Okay, and so the sum will come out to 16 times 4/5. Okay, so 16 times 4, that's, let's see, 84/5. And let's see if we can get a decimal for this. Sorry, this is 64. 1 times 4, that's 40, and then 24, 64. Okay, so 64/5, that's going to come out to 12.8. 12.8. So that's the sum. Okay, and this is again pretty interesting. We're summing up infinitely many terms, positive and negative, and it comes out to a finite value. Okay, let's look at the next one. It says determine the sum of the infinite geometric series. Let's see if it's convergent. The common ratio we can see is -1/3 here. And so S infinity is A, which is 9 over 1 minus -1/3, which is 1 plus 1/3, right? Negative becomes plus. And so this is the same as 9 over 1 is the same as 3/3 plus 1/3. This gives us 9/4, which is the same as using the same multiplication division trick. 9/1 times 3/4. So this is 27/4, which will come out to, let's see, 27 divided by 4, 6.75. Okay, so the sum comes out to that number. All right, let's have a look at some word problems. So it says a ball is dropped from a height of 81 meters and rebounds to 60% of its previous height. Find the total distance traveled by the ball after it stops bouncing. And so the trick to this problem is to realize that the ball never really stops bouncing. So let's draw a diagram. First, the first drop is 81. And then the ball is going to rebound to 60% of the height, so somewhere lower. Hit the ground and again rebound to somewhere lower, rebound to somewhere lower, rebound to somewhere lower, and so on. And so this will keep going forever. So you have to recognize this as an infinite series, and we'll see in a second that it's geometric as well. Okay, and we did a problem similar to this in the normal geometric series worksheet. And so I talked about the logic behind this. If you guys are wanting more practice with this, you can go ahead and watch that video as well. Essentially, what we're going to do here is we're going to ignore the first bounce, the first fall of 81 meters. Okay, when the ball is let go from a height of 31 or 81 meters. This is because The first fall is kind of like a special fall because it happens by its own. And then everything else after that, if we notice, comes in pairs, right? So when the ball bounces, it goes up to a height and it falls down the same height. Again, here we go up to a height and we fall down the same height. So everything comes in pairs, okay, except for that first one. So let's write some stuff down. So it looks like we're gonna have a travel distance traveled of 81 meters plus this distance. Let me use that pink. So that's the 81. This distance is going to be 60% of 81. Okay, 60% in decimal is 0.6. So I'm going to do 81 times 60%. Right, this is how we find 60% of 81. And it's going to fall the same distance. Okay, so it goes up a distance and falls down the same distance. So that's essentially like doing the same thing twice. Okay, so I'll just multiply it by 2. Okay, for the next bounce, so that's all the way down to here. For the next bounce, it's going to be 60% of the previous value. So what was the previous value? The previous value was 81 times 0.6, right? We don't think about the times 2 because that's just to signify that there's two pieces to the whole distance here. So let me erase this. Okay, there we go. So this is the previous height, and we want 60% of that. So we multiply by 0.6 again. And again, here, it goes up a height, and it falls down the same height. So we're going to have to multiply this by 2. Okay, and we're going to keep going like this forever. Okay, so I will rewrite this as 81 plus, and then I'm going to factor out the 2. So let's imagine factoring out the 2 from every term. That's going to leave us with 81 times 0.6 plus 81 times 0.6 times 0.6. So all the 2's are gone, right? They're out here. Plus dot, 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 close bracket. Okay, so then the total sum, we have a geometric pattern here, right? Every time we are being multiplied by 0.6. So we go from this term to this term that has two 0.6s. So it's been multiplied by 0.6, right? So we can conclude that our R value is 0.6. Okay, this R value is between -1 and 1. So this series is convergent, and we can find its sum. So the total distance, I'm going to do that here. So the total distance will be the 81 here for the first fall plus 2 times, and we know how to find the sum of this guy. This is an infinite geometric series. So we write down the first term. This is our first term, right? It's not 81, it's this guy. All over 1 minus the common ratio of 0.6. Okay, so let's see, what is that going to be? That's going to be 81 plus 2 times, here, let me do 81 plus 2 times 81 times 0.6. So 81 times 0.6 is 48.6 all over 1 minus 0.6. That's going to give us 0.4. Okay, So let me calculate this. So 81 plus 48.6 divided by 0.4, that's 121.5. So we have 2 times 121.5, and I'll continue it here. It's a little bit messy, but I think we'll get through it. So multiply that by 2 and add, I'll do that in the next step. Okay, let's see. Let's do this by hand. I messed up my calculator. So this is going to be 243. Did I do that right? 2 and then 3. Yeah, and then plus 81, we're going to get what? 344. Actually, sorry, that's 324. 243 plus 81. Yeah. Perfect. Okay, so let's have a look. Is that the only thing they wanted here? Yeah, that's the only thing. All right. Okay, so let's just box this answer up. This is the total, let's put meters here. This is the total distance traveled by the ball. All right, let's have a look at the next problem. So it says a company offers a salary package where the initial salary is 40,000 and increases by 5% each year indefinitely. What is the total lifetime earnings of the employee under this package? And we're assuming the employee lives forever, right? And continues to get this money for forever, just as a hypothetical problem. Okay, so let's think about this. Let's write this down. So we have 40,000 for the first year. And what's the salary the next year? It's going to be 40,000 with a 5% increase. So the decimal value for 5% is 0.05. And how do we write down a 5% increase? So we have our original salary of 40,000 and 5% more. The way we indicate that is by putting a 1 up front. So it's 1.05. Okay, so the common ratio here is 1.05. Okay, and we can confirm this. So what's the salary going to be the next year? It's going to be the value we had the previous year, the 40,000 times 1.05 times another 5% increase, so 1.05 again. All right, this R is outside the range of -1 to 1. So this series isn't convergent. Okay, it's actually divergent, meaning it goes out to infinity. And you can see this, the salary is increasing every year for infinity. So the sum here is going to be infinity, right? So this is actually going to be a divergent series, okay? And the answer is infinite money, which is a very nice salary if you live forever. All right, let's have a look at the next one. It says an investment of 5,000 earns 10% interest annually, compounded yearly. Find the total value of the investment after 15 years. Okay, so I threw this problem in here just to make sure we still remember everything from the previous unit, which was normal geometric series. This isn't infinite geometric series anymore, right? This is 15 years. So we're going to have to use this formula from the previous unit, or not previous unit, sorry, previous section. Okay, so first we have, and I have done a problem like this, so if you want more practice with this, go to the video I did on normal geometric series and you can find more problems like this. So first we have 5,000 and then what's the next term after that? Oh, sorry, we aren't finding a sum here. We're trying to figure out what the 15th term is, right? Okay, let me write this out and I'll explain why. So we want 5,000, we have 5,000 for the first year, and we earn 10% interest. So how much money are we going to have after 1 year? So we're going to have the 5,000 and 10%. So 10% in decimal is 0.01. And if I want a 10% increase, then that would be 1.10. We add a 1 out front. The year after that, I'll have the same amount I had the previous year times another 10% increase. So times another 1.10. Okay, and we're going to keep going like this. Okay, so this is technically year 0. It doesn't count. This is how much we start with. This is what we get after year 1. This is what we get after year 2. And we want to know what we get after year 15. So this is actually isn't a sum formula. This is a problem we can solve using this formula. AN is equal to A R to the n minus 1. Right? Our geometric sequence problems. So maybe I should have included that formula here as well. There we go. Okay, let's go back down. Okay, so yeah, let's find the 15th term here. Let me see if I can maybe shrink all of these down. Yep, so let's shrink all of this down, move it over here. All right, so let's go ahead and figure out what the 15th term is now. So A15 is going to be equal to the first term. Now our first term, from the way I've numbered this, is going to be this guy. Okay, so it's not going to be the 5,000. So we're going to have 5,000 times 1.10 times the common ratio, and the common ratio is 1.10 to the power of, I want the 15th term, so this is 15 minus 1. All right, so A15 is, let's see what 5,000 times 1.10 is. So that's, should have guessed this, 5,500 times 1.10 to the power of 14. So let's see what that is. 1.10 to the power of 14. Okay, and multiply that by 5,500, and we get 20,886.24, and this is roughly. So that's how much money you would have in 15 years. All right, let's move on to the next problem. So these problems, they're pretty neat. So I hope you guys enjoy them. They're good candidates for test problems, I think. So that's why I included them. So it says, for what value of x will the series have a finite sum? Okay, and this might look a little bit complicated to begin with, but it's actually quite simple. So what's the condition to have a finite sum, to be convergent? The condition for infinite geometric series to be convergent is for the common ratio to be between -1 and 1, right? Okay, so what's the common ratio here? Let's try to figure that out. Well, let's just observe something first. From this term to the next term, we seem to be multiplied by a value of 1/4 x squared, right? If I multiply this by 1/4 x squared, I get 1/16 x to the 4. If I multiply this by 1 over 4x squared, I get 16 times 4 is 64. X to the 4 times x squared is x to the 6. So the common ratio is this, right? And I want 1 over 4 x squared to be less than 1. Okay. Now, why did I just write this down as being less than 1 and not less than 1 and greater than -1? Well, because the x here is squared, and so it's impossible for us to get a negative number here. So this guy will always be greater than -1, just because it's impossible for any number I put into x to give us a negative number. Okay, so I'm going to solve it like this. So here we just have to multiply both sides by 4, and that's going to give us x squared is less than 4. I can square root both sides here. Okay, and that's going to give me x, so square root. And over here, we're going to get that x is less than 2. Okay, now, I haven't done a video on solving inequalities, which I will do in the future, but there's something a little bit more tricky going on here. So this says that x squared has to be less than 4. X being less than 2 is only part of the solution. So not only can x be less than 2, x actually has to be less than 2 and also greater than -2. The reason for this is that x, if you look at the original expression here, the numbers that we plug into x are being squared. So we could plug in a negative number here, like -3, and when it gets squared, it's going to give us 9, which is definitely not less than 4. So the reason I had to restrict x to be between -2 and 2 is because I don't want the number that gets substituted in x, positive or negative, to be larger in magnitude than 2. Okay, so that's the reason. I hope this makes sense. I will do a video on solving inequalities in the future, and we're going to be dealing with problems like this. But for now, we're just going to think about it conceptually. The reason x has to be greater than -2 is because I don't want to allow numbers like -3, because if I plug in -3, -3 squared would be 9, and that doesn't hold here anymore. Okay, so the answer for this question is this. Another way of writing this is that the absolute value of x has to be less than 2. Right, so we are saying positive or negative, the size of x, the magnitude of x, has to be less than 2. So actually, this is a more compact answer. Okay, let's try another one. It says, for what value of x will the series 2 plus 6x and so on have a finite sum? So same idea. Let's find the common ratio. So from 2 to 6x, it looks like we are being multiplied by 3x. Okay, let's test that out. 6x times 3x would give us 18x squared. So this seems to be the correct common ratio. And again here, I want 3x, I want this common ratio to be between -1 and 1. Okay, so what I can do is I'll divide everything by 3. So when we are solving inequalities like this, if we divide the middle term by 3 to get rid of this 3, I also have to divide the numbers on both of the inequality by 3. Okay, so this is going to give us -1/3 x and 1/3. So x has to be between negative 1/3 and 1/3. And another way to say that is that the size of x, the magnitude of x, has to be less than 1/3. Okay, so if that's the case, then the series will be convergent. All right, so I'm going to pause the video here. And in the next video, we'll go over the advanced problems. Again, not super hard, but this video is getting a little bit long, so I'm going to leave this for part 2. Okay, if you guys have any questions, as always, feel free to put it in the comment section, and I'll do my best to answer them. All right, see you guys in the next part.